Okay, so let's try to prove the property that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So we know that A and B are events, and therefore there's some subset in the sample space. So we can have two cases. So the first case, which is the simple case, is that A and B are disjoint events, right? Disjoint subsets. What this means is that the intersection of A and B is the empty set. Therefore, we know that by the additive property of the probability axiom, the second rule, for which applies to disjoint sets, if A and B are disjoint, then the probability of A union B is equal to the probability of A plus the probability of B, right? And we know that, of course, the probability of the empty set is 0, right? So this does not, this follows from the axiom, and we do not have any contradiction. So the second case, and the more interesting and more difficult case, is if A and B are not disjoint events. Right. So what this means is that A intercept B is not the empty set. So again, we can always have in our mind the mental picture, right? We have some sampling space, which sometimes you don't have to draw, but we know that we have some set A and some set B, and they're not disjoint subsets, so therefore there's the intersection is not empty. But the only information we have at this point is we know exactly how the probability of disjoint subset should be. So when I look at the union of A and B, so A union B is really something that looks like this, right? So I can think about the different ways that I can create disjoint sets. So for example, I can break up A union B into two disjoint sets, where one is like this and the other one is set B, right? So this is set B, and this set is the set such that the element or the outcome is in set A, but is not in set B. Right. So in this case, so we can indicate this set with this notation. It's a set subtraction notation. So we know that then the probability of A union B is equal to, because these two things are disjoint subsets, it's equal to the probability of this new set A minus B plus the probability of B, right? Because now we still have two disjoint subsets, so by following the axiom of a probability, we know that the probability of the union is the sum of the probability of the disjoint set. But furthermore, we know that this, right, this little moon thing, this is really A if we subtract out the intersection, right? If we subtract out this part. So we know that this and these two are disjoint subsets. So I'm sorry. So what we can represent this moon thing is we can represent this as the probability of A minus the probability of A-intercept B plus the probability of B, right? That's how we get this this A minus B subset. This moon thing is by taking the set A and subtract out the part which is A-intercept B. So therefore, we can see that you can rearrange this as the probability of A plus the probability of B minus the probability of A-intercept B, right? And this just use nothing but the axiom of probability, and so the thing is proved.